Hello, my name is Liam Fraser, and this is my individual project. So the objective of my experiment was to create a series battery using pieces of zinc and copper immersed in a saltwater solution and investigate the behavior of the battery as the concentration of the salt and the load on the battery changed. Personal motivation was when I was researching this topic. I found how closely related it was to real batteries, and I found that very interesting, and so I decided to research it. Social cultural significance. As we move away from fossil fuels today and real world technologies and more towards electricity based things, this has a real application to the real world, as well as in underserved communities where they don't have access to high grade technology, and this could be a vital source. So here's the model of my experiment. So the first experiment on the top, paper towel with NaCl solution, and then two electrodes. So the electrodes flowed from the zinc to the copper, and the NaCl flowed in the other direction to balance the charge. So the charge concentration of the ions was equal to the charge concentration of the electrons to allow the current to continue to flow and the charge to be balanced. Here's my system schema. So here's my research. Um, so I discovered from research is that the same principle on which the saltwater battery functions is used in almost all commercial battery technologies, making my experiment very pertinent to the current state of the art and to the current state of batteries. So here's my battery setup, and in the black there are other commonly used batteries like AA, AAA, and batteries using cars. So here's more of my research. So I found in one research article a 16 cell prototype generated about 12 volts of battery and 20 milliamps, which was very similar to the setup that I had. This is enough energy to power a light bulb very reliably, so that could be used in poor communities on coastal places to as an alternative. So the fundamental building blocks of a battery are the anode, the cathode, and the electrolyte. This is consistent throughout any battery. So the internal resistance is the opposition to the flow of the electric current within the battery itself. This is caused by the ion resistance, like the NaCl moving throughout the solution, and the surface resistance, including corrosion or deposits. Those are my sources for the research. And this is my actual experiment. So this is the oxidation reduction reaction that was going on. So as seen from that redox reaction, the zinc anode is consumed in the reaction, producing zinc ions and hydrogen gas. So most of the electrons are going to the hydrogen gas for the reaction. So here's the setup again. And so the experimental setup, this was a 0.017 mole solution of NaCl. So the wire is connected to when the wire is connected, the voltage rises from 0 to 0.24 volts instantly, showing that something must be happening. The N and the Cl ions don't have time to fully go across. So I know there must be an electric force or electric field from the charges that's pushing the N and the Cl over instantly. So here is my experiment 2. So it's the same as before, but just 3 in series to generate a higher voltage. So as the NaCl solution completes the circuit because of the flow of Na ions towards the cathode and the Cl ions towards the anode. So this is just in the individual water glasses. Here's my overall experiment results. I found as the concentration of NaCl increased, the power and the current generally increased as well as the voltage. Here are some graphs that I had. And one interesting thing I found was the power to the resistor is not maximum for the lowest resistance. This is due to the maximum power transfer theorem. Basically, just states the internal resistance is equal to when it's equal to the load resistance, the power is at its maximum. And this is showing that higher molarity of NaCl led to a lower internal resistance. So the main results from experiment 1 was that the electric field propagates. So so when a charge imbalance first happens, the Na and the Cl in the paper towel push the ones that are on the other side, which is how it's able to happen so fast and how the charge is balanced so quickly. For experiment 2, the higher concentration of NaCl in the electrolyte, the greater the current that is possible to the battery. Those were the main findings. Sources of error, temperature in the water, and the erosion on the copper of the zinc electrolytes. But I made sure to sand down the erosion so there was very minimal. I used very high accuracy tools, and I kept the temperature very constant. Here is my uncertainty. Here's my class problem. Thank you.